So hi everyone, good afternoon to everyone. The slides I haven't gone through the legals of Google, so I don't have the exact numbers, and whatever I have here is pretty much available open source. Available otherwise. So the main intention of this talk is to understand the challenges in AR VR and see how AI is trying to help it make it little better. I hope everyone knows about augmented reality, right? Like we had an app which is called Pokemon Go, which is very famous. So where you kind of place an object on the reality, either by superimposition or by other means. Whereas here you have an app which kinds of projects an image over to the bill, $1 bill. So there are different types of augmented reality by superimposition or by merging with the real world, and we have seen applications of this. And when it comes to virtual reality, we kind of get into completely an immersive world where we don't have any trace of the real world. So most of the applications have been, like gaming, and some of them have been educational as well. And there is a lot of applications that developed for training, like especially defense forces for this. And so now we have something called, like both AR and VR are kind of old school. So we have something developed out of combining both of these. That's called a mixed reality, where let us take this scene, right? We see a man sitting on a table, and we see an object, or an elephant for this matter, holding an object, a ball, and sitting on the same table. So when you see this, it feels so natural and real, right? But to get there, what are the challenges we have? Can anyone guess, like what are the challenges we may have, thinking a very top level or abstract sense? For example, if let us say that I am using my phone to place the elephant on the scene, and I can touch anywhere on the screen, right? But the object has to know where the table is, and actually it has to sit on it, right? It can be 1 inch above or 1 inch below, but that will give that error will be very much visible for human eyes, and it wouldn't give us a good experience. So to be very accurate, we need to know where exactly the table is. So that's one challenge. And the next one, what else do you see? Maybe we could turn off the lights or dim down the lights. Yeah. What else do you see here?
Shadow.
Shadow, very good, right? I think by turning off the lights, you got to know about the shadow as well. Yeah, shadow is very important. So you need to know where the light source is within the scene, right? So that's another challenge. And now, in mixed reality, one of the fundamental, principle is that like the object in the virtual world or which is placed in the real world interacts with you, and you are also allowed to interact with it. So this object has to know the sense of other objects in the real world, right? Which it otherwise doesn't have. So the object has to know what are other objects which it can interact with, like say a human being here, or it has a ball in its hand, and if it like puts it down, should the ball bounce back, or it should get lost and go as long as it's possible. So all these comes into play. So the fundamentals of mixed reality is that the objects interacts with you and you interact with the object. And the key challenge here is that like the object should understand or obey the physics of the environment. And for example, if you take the scene above, I think it's a game where the funny fox-like character bounces off the sofa and lands on the table to collect all the coins. So it should exactly know like in what angle it should jump and where it should land and how to collect the coins. Because when the user moves his frame of reference, it will be a different angle, right? So the object should have its own sense of reality. So that's a challenge. So here I will list the key challenges. The first one is like, I mean, it all comes under the broad umbrella of understanding the environment. The first one is like motion tracking. So we have something called inertial measurement units, which is called IMU, placed inside your device. It could be your smartphone. It's composed of accelerometer and other sensors. It gives you something called 6 degrees of freedom. Has anyone known of the 6 DOF concept? Okay, yeah, so for the other rest of the audience, so 6 DOF means 6 degrees of freedom. So you're able to go forward, backward, left, right, up and down. That's linear motions. And then you have the angular motions, which is like the roll, pitch, yaw, right? Which is commonly being sensed by a gyroscope. Like you turn this way and you rotate this way. So all these motions are captured in a single sensor or a combination of sensors, which gives you outputs about the orientation. So this orientation is being used by your app to calculate the motion. For example, let us say in the previous case, the fox is jumping, and while it's in midair, you try to move around. And the fox shouldn't change its orientation. It should go in its own orientation, right? So the inertial measurement units are used to track your future or current position from the past positions. And there is a lot of errors accumulated in this process, and we use AI for inertial modeling to model these sensors so that the cumulative errors down the line is very, very minimal. And the next challenge what we have is to understand the depth of a scene. I think this is a kitchen sink or some random room, like with some tables on the left and a wall on the wall on the left and tables on the right. So in the camera, you're able to see the depth that is being mapped. So this can be either through a normal camera or like a stereoscopic camera with extra cameras with different focal lengths, or it could be based on an IR sensor to measure the depth. So why do we need to know about the depth? Can anyone guess randomly, why do we need to know the depth of a scene for augmented reality or mixed reality?
3D effect we should get.
Yeah, that's correct. Yeah, 3D for the 3D effect. But these objects are themselves modeled as 3D assets, right? When the elephant is drawn, it's drawn with a 3D perspective, 3D mesh. It's not on a 2D picture. So when you place the object in the scene, you do see it as a 3D. But okay, let me help you. So what happens when you place for example, in the foxes near the person and far from the person? What is the difference that you see? Yeah, the size differs, so scaling has to happen, right? So you essentially have to have depth in order to project or make it like more user friendly or make it more realistic. So you need depth estimation. And the next one is like plane finding, right? When we go back here, right? So for example, when I place the object has to know the different planes in the scene and get placed on the plane as per gravity, right? Only then it will make sense for us. For example, if the elephant is floating in the midair, it wouldn't make sense for us. So in order to be more realistic, we need to have plane finding. And this plane finding has been pretty tricky in terms of oblique planes, or when you are not at right angles or orthogonal to the plane that you are in reference to. So different people like Google, Apple has come up with different concepts to understand like what exactly is the plane. And you can also do this based on depth mapping, but that becomes a costly process, because whenever all these seem very fancy, right? But think about that, you had to get all these features only by carrying a big, a big computer in your head. It will be very difficult for you to use it. So you want it as compact as possible, so power and performance comes into play. So with your mobile device, you have to be very conscious of not using the sensors all the time for all the features. So you don't want to use like the IR camera based depth mapping, you want to use something else. So they use ray tracing and other concepts to understand, or augmented oriented points based on the orientation of the points in the scene, or also based on the edges of an object. They try to understand, what the depth of the object is, and not depth, sorry, what the angle of the plane is. And once that is identified, then you are allowed to place the objects, and that can be straight or oblique or slanted. So, for example, this is a kind of a composite scene in which the objects placed farther or scaled down. As they come closer, they are large. But of course, you will see anomalies because things are not completely developed. When they go towards the side, they are supposed to tilt based on the curvature of the road and all those things. So they need to have a complete understanding of the plane. And for example, a lot of places we have curved surfaces, right? So they kind of do a piecewise linear estimation of the curved surface into linear planes or planar surfaces, and then go for understanding the planes and placing the objects. So here A helps in terms of how granular do you want to go into for a particular scene. For example, you don't want to go do all the kind of piecewise reconstruction for a scene which is very far in the image, right? Because as a user you don't see it clearly, the deltas or the errors. You want to do only at a local region or a region which is of interest for you. So all these are identified by AI-based algorithms for us to help us make the experience more realistic. And the next one is lighting. So here, of course, there is a augmented image and a line is placed. We do have a lighting. For example, I think the light source is on the left extreme, so we see the shadow on the right side. And so we need to kind of understand the light source when there is no light source visible in the scene, right? How do you guess that? Probably can use the shadows from the other objects. If it's dynamic, then it gets more tricky. If it's more than one light source, then it becomes more complicated. So AI does help us in all these areas to identify which is the bright light source and just focus on that. But if we have enough compute power or if that's enough scope for the app, then have more complicated algorithms to capture the actual shadow. So far for all the, I think, the demos that is out online, I don't think there was a situation in which the object is placed behind the real objects. Like say, the line was never placed behind the people. I think that is still work in progress.